Welcome everybody, I'm Attila and today I'd like to talk to you about authentication. More specifically about passwords and why I don't like them. But what do you mean you don't like passwords? Well, passwords are inconvenient, hard to remember, and really not fun. I'm the Principal Engineer of Barion payment, I have more than 15 years of web development experience, and I work on fintech solutions every day. We are going to talk about why passwords are bad, how we can come up with a better solution, and what do we actually need to implement these solutions. Well, let's start with passwords. As I already mentioned, they are really inconvenient, not very secure, and they are hard to remember, and we have a lot of information on how we can create a password. Most of you heard that you have to create a complex password with exotic characters in it, probably something that nobody could guess, and frankly, nobody would remember. Well, one thing that you can improve on passwords is by creating a second factor throughout your authentication. This second factor could be a push notification that you receive on your phone, or either a one-time password that you possess and you can type those tokens into the prompt when they ask you for it. Well, this is better, but not the best. This can be extended with receiving an SMS message, even someone calling you, for example a robot, and that robot can ask you something in a robot voice, and you have to type it into a prompt as well. These are better solution because now you are not bounded by your only thing that you know, your password. A second factor comes in play, and this makes it more secure. As of today, the best solution that you can have for your authentication system is implementing a passwordless authentication. This means that you create something that the customer, the user, uses instead of a password. In Microsoft environment, this is called Windows Hello. In an Apple environment, this could be either Face ID or Touch ID, and in the Android Google environment, this could be either a face check or a fingerprint touch. This is how it looks like. This is a slide from Google. This is how they imagine that this authentication could look like for a convenience scenario. You type in your username, you touch your screen, and you're immediately logged in. This is not something that was invented yesterday. Around 2012, some of the big companies realized that the world with passwords is a hot mess. And they try to come up with a solution, and the best solution they come up with is just to get together and talk about how we could create a new way of authenticating. These companies created the FIDO Alliance. The FIDO Alliance is an open industry association, and they have a single goal to create a passwordless world where you don't have to use any inconvenient methods for logging into your favorite software. They created a WebAuthn method, short for Web Authentication, that should be the next generation of authentication processes. But what does this WebAuthn mean? This is short for Web Authentication, and this is basically a standard for communicating between parties, between client and server, between client and hardware. This is basically a JavaScript API that was standardized by the Worldwide Consortium. As I mentioned, this protocol is used by the browser and used by our servers as well. So this is a two-way protocol. You have to implement a JavaScript API as well as a server API. But what is an authenticator? As you can see on the screen, it is displayed as a mobile device, but it can take up many forms. The authenticator has to do several things. First of all, it has to be secure. It has to create and reliably create public-private key pairs and store the private key in their hardware storage somewhere. These public-private key pairs are called credentials, and oftentimes with certain capabilities they are called passkeys. These authenticators has to be interactive as well. It means that the WebAuthn protocol, the WebAuthn standard, specifies that every authenticator has to handle some kind of gesture. It could be either a fingerprint scan, a face recognition, or any type of gesture that proves that the customer wanted to authenticate. And last, these authenticators have to be able to test for user presence, so they have to make sure that the customer is around the part where they want to log in. An authenticator most probably is already in your pockets, because most of these new phones, most of the current mobile phones possess the technology to act as an authenticator, but it can be either your Mac or PC, and in some cases you could buy those small keys that act as an authenticator called YubiKeys. They differentiate between two types of authenticators. The two types are platform authenticators or cross-platform authenticators. Platform authenticators are bound to the device itself, while cross-platform authenticators do much cooler things. They can authenticate with different devices. For example, your phone could be a roaming authenticator or a cross-platform authenticator. You can use your phone to log in to several devices as well. After this WebAuthn protocol was introduced, they took several years for the browsers and for the industry leaders to implement this protocol into their software. In 2018, Chrome and Firefox led the way and implemented in their browsers, and shortly after, Edge, the version 18, released the web authentication support as well, and finally, in 2019, WebAuthn became an official standard. And as always, in 2020, Apple started to support this protocol as well. They released it in iOS 13.3. And nowadays, Google even recommends this option as your default authentication method, your default process to log in your account. So I guess we could say that this is widespread right now. Now, we saw how it all came together. Let's dive deeper and see how it actually works. But first, well, most of the cases you have a server side and the client side. The architecture of it consists of two parts. There's a relying party and there's a client platform. In your relying party, you have your server application, and most of the server application have some kind of user storage. On the client side, you have your browser, and in your browser there's a client-side JavaScript library or the JavaScript engine. Most of the time, your server application communicates in some way with your client-side JavaScript code. Now, this is a pretty standard way of doing client-server applications. Let's insert the passwordless architecture inside it. In your browser, there is already a WebAuthn, a web authentication browser API implemented. Your client-side JavaScript communicates with this API. This API communicates with the platform authentication API that is inside your platform, your Windows, your Apple device. And this platform authentication API finally communicates with the authenticator itself. This is usually a piece of hardware inside your platform that I already mentioned consists the secret that you created. In certain scenarios, in case there is no platform authenticator inside your platform, or you are not using one for your authentication, you use a roaming authenticator or a cross-device authenticator. This roaming authenticator communicates with your platform through a protocol called CTAP. This is a client to authenticate protocol that was created to communicate reliably with the authenticator. On your server side, you create your FIDO2 compliant API, and this FIDO2 API communicates finally with your client-side JavaScript code. A FIDO2 API is just an umbrella term for these technologies. It was a marketing term to use instead of WebAuthn. FIDO2 consists of WebAuthn and CTAP. The WebAuthn protocol consists of two ceremonies. One of them is the registration, and the other one is the authentication. Now these names have different meanings, so they created, or in the specification it is said that the registration is called attestation and the authentication called assertion, so you might come across these kind of terms as well. Let's start with the registration. They try to create a very simple solution for this complex authentication problem. So I try to create a chat conversation between the two parties. Your device wants to register itself and your account to the server side. This is communicated to the server side, and your server application, after validating this request, sends a request to the mobile side and asks for a public key. Your device, inside your authenticator, creates this public-private key pair and sends the public part of it to the API. And basically, that's all there is. The API registers this public key, and from a bird's eye view, these are all the steps needed to register your credential with the FIDO2 API. During this process, you might come across such screens that are displayed here. This is with Windows Hello in a Chrome browser. This looks a bit different in a Safari on a Macintosh, but the basic steps are the same. After registering your credential with the server API, of course you have to use that credential to log in to the system. The steps for the login are as simple as the registration steps. You say to the server that you like to sign in. The server registers this request and asks for and gives you a challenge that you have to sign on your device. Your device in your authenticator creates a signature for this challenge with the private key located in the authenticator and sends that signed challenge back to the server, where the server verifies this signature and communicates to the mobile device that this authentication was successful. As simple as it is, not all the softwares and not all the services used on the internet implemented it already, but here are a list of big companies that already provide you a passwordless authentication method. Bonus points if you are able to find technology-defining industry leader logo here. Although it is an emerging technology and all the major browsers and platforms already support it, not all the features are currently supported by all the browsers and platforms. This table shows you what are some of the areas that you might find hardship towards integrating this passwordless authentication. I included a link here where you can see the whole table. This kind of authentication requires some hardware from the user. Now, what happens in scenarios where the user doesn't have this kind of technological advancements? For example, they have a Windows device that only has Windows 7 on it, which doesn't contain Windows Hello on it. Or even better, what happens if the customer opts out from Windows Hello? Now, you have to consider these scenarios, and you have to create a system where everybody can log in. This means that you have to create fallback mechanisms for users that doesn't meet the required technological advancements or the hardware for this kind of authentication. It is important to notice that when falling back for other authentication methods, try not to create security holes and try to create fallback mechanisms that are almost as secure as the passwordless authentication method. The best thing that you can do here is urge the users to use multiple authenticators. Now, multiple authenticators mean that either you have your phone where you can authenticate and create also an authenticator credential on your Windows or Mac device. And this means when you lose any of them, you still have a way to log in. Your second best option is to use your mobile app that comes along with your software, if you have one, and create a push notification system where you can approve your login attempt there. This is not as secure as using passkeys, but it can still be hardened, for example, with number matching that tests for the user presence. And lastly, you can use any type of authentication that deemed necessary for you or you already have as a fallback mechanism. Just be aware that this last part, your last fallback line, might not be as secure as your previous two and might be a backdoor for hackers to use that authentication method to get in others' accounts. Alright, let's see what you have to do to create and implement a system like this. First of all, you have to create an API for your JavaScript code that can be called and mitigates this whole process, this whole server client-side communication. The second step is that you have to create a UI where you don't require a password from your users. And of course, most of the systems already have an authentication system. So in those scenarios, the recommended way is to let your users in and urge them to create a credential for themselves. As we touched on it earlier, you have to have some kind of recovery options. It is not recommended to let your users have only one device which they can use to log in. So implement the earlier mentioned recovery options and don't forget to keep them secure as well. And finally, you should migrate all your users and try to find ways where you can educate them about how secure this new option and how convenient this new authentication option is. When it comes to implementing your own FIDO API, there are several libraries that you can use, any kind of programming language that you already know can be used to create a FIDO API. In case you don't want to do that, there are several commercial products on the market that you can use as a software as a service, and they provide passwordless authentication and identity management as well. The remaining part of this talk, I'd like to guide you through how you can implement your own FIDO2 API in a .NET environment. For that, we are going to use this FIDO.NET lib that is displayed here on the slide. As a reminder, here is the registration ceremony. We're going to start with that one. First, you have to create a JavaScript object that contains all your preferences and all the things that you'd like to set for this whole process. I'm not going to get into the details here, but there are several things that you can control over the whole process. First, you have to call your credential creator API. For that, you create a JavaScript object and call this API. On the API, most probably you have already a user storage, so you request your user from this storage based on the username that you received. You create several different objects here to control the process. For example, you set whether you want to accept credentials that are discoverable or credentials that are only requested by name. As always, the FIDO2 library does the heavy lifting and creates a new credential option here for your user. The credential option is basically JSON object that contains the challenge, and this challenge is something that the authenticator has to sign. So as you can see in this JSON response that you received in response for your request to start the registration, you receive several different things here. One of them being the relying party which in this case is localhost because it's a locally run server, but most probably it's going to be your company's name. You have your options here, your authenticator selection options, you have your extensions. This JSON also contains information about the cryptography algorithms that the server uses. So basically, this is an object that you have to pass to your WebAuthn API, so the WebAuthn API in your browser can do its thing. In the WebAuthn hardware, the authenticator itself, most of the strings that you receive from the API are stored as byte arrays. So in almost every step, you have to convert those JSON strings to byte arrays and from byte arrays to JSON as well. And this is what you can see here in this slide, that we convert these JSON information that we received into byte arrays. Finally, you call the Navigator API of the browser and you ask for a credential to be created. This make credential option that is passed to this credential API is the whole JSON object that you received from your FIDO2 API, apart from the part where you recreated those JSON strings into byte arrays. This will result in these screens. The customer will be asked to provide a proof of their presence and touch the screen or look into a camera, or any biometric could be used. And finally, the browser and the authenticator on your platform creates the credential and notifies the user that the credential was created for, in this case, for localhost and for the name Attila. It is important to notice that this public-private key pair is only used for this relying party. This means that even someone gets a hold of this credential, it cannot be used to a different service. So stalling these credentials would not mean that the hacker could get into any of your other accounts or any of your other services where you are registered. After the WebAuthn API created the credential, you receive back this newly created credential information, basically the public key of the credential. Again, you have to convert from the byte array to string objects, so you can into base 64 encoded string objects, so you can communicate it through HTTP API to your FIDO server. You create a new object here that will be passed into your API. This is the next step of the credential registration process. After the authenticator created credential, you have to communicate it with the API. After receiving the request from your client side, there's only one real thing that you have to do here on the server side, is to call the FIDO2 libraries make new credential async method. And this method will verify the signature and provide you a credential result, which is basically an object about the credential that was created. Now, this method does not save this credential, so this is something that you have to do on your own. This is up to you where you store it. Probably next to the user object would be advisable. The return response is a big object that you receive on the client side, but this is not something that you have to handle more. You just have to look for the signs here, whether you were successful on creating the credential or not, and handle your scenario accordingly. After registering your credential, you can use it to sign in next time. This means that you don't have to type your password again, never again. You have to provide your credential instead of it, which is a much more convenient approach. For that, you also have to call your FIDO API and tell the API that, hey, this is a new authentication request here. This is the username I'd like to authenticate, and send this request to your API. On the API, you get your user based on their username. You check whether it's a real user or whether this user can log in or not. And you call the get assertion options method of the FIDO2 library, which basically creates a new challenge, a new object that contains the challenge for the client side. This is the response that you get from your API. As you can see, there is the challenge string that you have to sign with your credential, with your authenticator, and you can see a list, an array of credentials here that belong to this username that you sent to the API. In your client-side code, you convert these strings to a byte array and call the Navigator API again from the browser, but this time we do not create a credential. We use the navigator.credentials.get method, which gets all your credentials that belong to this relying party and for that credential list that the server provided for the client side. Once the user provides proof, provides biometric authentication, you receive the credential information, the signed credential, the signed challenge on your client side. You create an object from it. As you can see, we have to convert from the byte arrays again. You create a request from it and send your request to your FIDO2 API. Your API now has to verify this signature, basically has to decide whether this signature is valid, whether the user signed it with the proper key or not. For that, you use the make assertion async method of the FIDO2 library, and in case the result is successful, you can log in your customer. Now, this is something that I need to highlight. This FIDO2 library does only the verification, the signature checking, but does not authenticate your user into your system. So this is something that you have to do after this whole verification signature process completes. After the verification and the authentication happened, you send a very small amount of data back to the client side, indicating that your user was successfully signed in. And as you can see, even the count of how many times your user used this credential is provided to you. This is the whole process of registering and authenticating your user with WebAuthn and with the FIDO2 API. With these libraries that were listed here for every programming language you imagine, it is really a simple process, does not require heavy coding experience. I listed some resources here that you can use. There are many websites where you can read about how passkeys works, how web authentication works. These are just the ones that I favor the most. Thank you very much for your attention. This was my presentation about how you can include and integrate this passwordless authentication in your website, in your system. I hope it was clear. I tried to demonstrate that this is really easy. From a coding point of view, you have many libraries that you can use, and from a user point of view, this is a really convenient but very secure way of authenticating.